Hello again. In this video, we'll be taking a closer look at L'Hopital's rule. And just recall that we can only use L'Hopital's rule when we have an indeterminate form, like infinity over infinity, 0 over 0, and then some interesting cases like infinity to the 0 or 0 to the 0th power as well. In all of these cases, we would be able to use L'Hopital, but if we have something like 0 over infinity, that would not be a case where we would use L'Hopital. So only in these cases described over here. So I'm going to go over two quick problems to demonstrate the use of L'Hopital's rule. The first one, the limit as t approaches infinity of natural log of 3t over t squared. Now, to determine if we can use L'Hopital's rule, let's plug in t equals infinity, and we would get natural log of infinity, which is indeed infinity, over infinity squared, which is also infinity. So in this case, it is perfectly all right for us to go ahead and use L'Hopital. And remember, for L'Hopital's rule, we're just going to take the derivative of the top divided by the derivative of the bottom. I'll put an L here by my equal sign just to indicate that we're using L'Hopital's rule between these two steps. So the derivative of the natural log of 3t would be 1 over 3t. And then don't forget chain rule, multiply by the derivative of the inside function, which is 3t. The derivative of that would be 3, of course. And then divide by the derivative of the bottom, which is 2t. To simplify this, those 3's are going to cancel out, and we'll have 1 over t divided by 2t, or times 1 over 2t. So 1 over 2t squared. Now remember, we're taking the limit of this as t goes to infinity. So we get 1 over infinity, which would go to 0. So that would be the answer for our first one. And that's a pretty standard L'Hopital problem. This next one, though, will be a little bit harder. So in this problem here, we would like to find the limit as x goes to 0 of x to the 1 over x. Let me make sure I got that down correctly real quick. My apologies. That's supposed to be the limit as x goes to infinity. Okay. So proceeding onwards, in this case, we would get infinity to the 0th power, which is going to be our third case of the indeterminate form. But you'll notice we can't really use L'Hopital right away because we don't have a top function and a bottom function. So any problem like this where we have some like infinity to the 0th power, 0 to the infinity power, 0 to the 0 power, any of those kinds of things, we'll want to use this strategy I'm about to show you, where we call y equal x to the 1 over x, and then we'll take the natural log of both sides. And that seems weird, but you'll see why in just a second. So natural log of y equals natural log of x to the 1 over x. Now, the reason that this is helpful is because we can use that logarithm rule where if we have a power on the inside of the logarithm, we can just bring that out in front. So, in fact, simplifying this just a little bit more, we're going to get natural log of y equals 1 over x times natural log of x, or just natural log of x over x. Now we do have a top function and a bottom function, and we'll go ahead and take the limit of that as it goes to infinity and see what happens. All right. So the limit as x goes to infinity of the natural log of x over x, and if we plug infinity in, we would get infinity over infinity. And just quickly using L'Hopital's rule here, 1 over x divided by 1 And just like that previous problem, our limit would go to 0. Excuse me. Now this is where we have to be a little bit careful, because notice we didn't take the limit of y. We took the limit of the natural log of y. So if natural log of y is equal to 0, we just have to undo what we did previously by taking the natural log and take everything to the e power. And so in this case, we would actually get that our limit is equal to 1.